Have you ever pondered what existed before the Big Bang? We often hear about the Big Bang theory, the widely accepted explanation for the birth of our universe. But what does it really mean? What is the Big Bang theory? Let's delve into this fascinating topic. The Big Bang theory is the prevailing cosmological model for the observable universe. It suggests that the universe, as we know it, started from the earliest known periods and has been expanding ever since. Picture, if you will, an extremely hot and dense point, much smaller than a single atom. This point, often referred to as a singularity, contained all the matter in the universe. Around 13.8 billion years ago, this singularity began to expand rapidly in a hot explosion, and thus, the universe as we know it was born. This theory paints a picture of a universe that has been expanding and cooling over billions of years. Over time, the universe cooled and matter formed, leading to the creation of atoms, stars, and eventually galaxies. The universe continued to grow and evolve, leading to the cosmos we observe today, full of galaxies, stars, and planets, including our very own Earth. The Big Bang theory brings together observational astronomy and particle physics. It marries the incredibly large and the incredibly small into a comprehensive theory that explains the structure and evolution of the universe. But this explanation of our universe's origin isn't without its mysteries. One of the most intriguing questions it raises is about what came before. If the universe began from a singularity in the Big Bang, what was there before it? This question challenges our understanding of time and space, and it's a query that has puzzled scientists and philosophers alike for decades. It's a question that takes us to the very edge of human understanding and scientific knowledge. But this leads us to an interesting question. What was there before the Big Bang? To delve into what was before the Big Bang, we first need to understand the concept of before. In our daily lives, we perceive time as a constant flowing stream, moving from past to future. Our understanding of before is directly tied to this flow. But when it comes to the Big Bang, things get a little more complex. The Big Bang wasn't just a colossal explosion that gave birth to matter and space, it also marked the beginning of time as we know it. This means that our conventional understanding of before doesn't quite apply. It's like asking what's north of the North Pole. In a universe where time started with the Big Bang, the concept of before the Big Bang is paradoxical, almost like trying to look over the edge of a flat world. So, if time started with the Big Bang, can we even talk about a before? The answer is, maybe. Some cosmologists propose a period known as the quantum gravity era. This era is envisioned as a time when the universe was so incredibly small, so incredibly dense and hot, that it was essentially a singularity, a point of infinite density and temperature. Yes, you heard it right, a point of infinite density and temperature. It's hard to wrap our heads around, isn't it? That's because in this quantum gravity era, the laws of physics as we understand them today cease to be useful to describe reality. We're talking about a time when the universe was so small that it was governed by the rules of quantum physics, not the familiar rules of classical physics that we experience in our daily lives. In this realm of the incredibly tiny, particles can be in multiple places at once, they can pop in and out of existence, and they can be both particles and waves simultaneously. So when we try to apply these quantum rules to the entire universe, our common sense understanding of reality gets a bit fuzzy. But let's imagine for a moment, in the quantum gravity era, the universe is thought to have been a quantum foam, a turbulent sea of fluctuating energy, where space and time themselves were subject to quantum uncertainties. This means that space and time as we understand them didn't really exist. They were just statistical averages, emerging from the chaos of quantum foam. This concept is mind-boggling, isn't it? But it offers a way to reconcile the two great pillars of modern physics: quantum mechanics, which describes the behavior of the tiniest particles, and general relativity, which describes the behavior of the largest structures in the universe, like stars, galaxies, and the universe itself. The quantum gravity era theory is fascinating, but it's also very abstract and difficult to test. It's a piece of the puzzle in our quest to understand what was before the Big Bang, but it's not the only piece. But the quantum gravity era is not the only theory out there. So, let's dive deeper into the other theories in our next segment. Enter the multiverse theory. With this theory, we journey into a cosmos far more expansive and complex than we could have ever imagined. Picture this. Our universe, vast and seemingly infinite, is but a single bubble in a frothy sea of cosmic foam. This is the concept of the multiverse theory, a proposition that our universe is just one in a potentially infinite collection of universes. Each of these universes, or bubbles, could have its own unique laws of physics. Some may resemble our own, with galaxies, stars, and planets, while others might be wildly different, with unfamiliar forces and strange forms of matter. The diversity could be as boundless as the multiverse itself. So, what does this have to do with the before of the Big Bang? Well, the multiverse theory suggests that our universe might have been born from an interaction with another universe. Picture two bubbles in a glass of champagne colliding and merging to form a larger bubble. It's a bit like that, but on a cosmic scale, and with a lot more energy. Alternatively, our universe might be part of a recurring cycle of expansions and contractions. This is known as the cyclic model, where the universe expands from a singularity, like in the Big Bang theory, then eventually contracts back into a singularity, only to expand again. This cycle could repeat indefinitely, with each iteration birthing a new universe. The multiverse theory, while fascinating, is still speculative. It's based on advanced physics and mathematics, but so far, we lack direct observational evidence. Yet, it's a tantalizing concept that has the potential to answer some of the deepest questions about our existence. As you can see, the question of what was before the Big Bang opens up a whirlwind of possibilities. The multiverse theory paints a picture of a cosmos that is endlessly rich and diverse, where our universe is just one story in an infinite cosmic library. Each universe could have its own beginning and end, making before a relative term. As you can see, the question of what was before the Big Bang opens up a whirlwind of possibilities. While we have theories, the truth is we don't yet know what was before the Big Bang. The cosmic curtain remains drawn, hiding the pre-Big Bang era from our scientific gaze. Our current understanding of the universe, while vast, is not without its limitations. There are still gaps in our knowledge, and this is one of them. Cosmology, the study of the universe's origin, structure, and evolution, is an ever-evolving field. We've made leaps and bounds in our understanding over the past century, yet we're still unlocking the secrets of the cosmos. The pre-Big Bang era is one of those tantalizing mysteries, a puzzle that challenges our very understanding of time and space. Our current theories, while intriguing, are just that, theories. They provide a framework, a starting point. But as we learn more, as we observe more, those theories may change. They may evolve, be discarded, or replaced with new ones. That's the beauty of science. It's a journey of discovery, not a destination. So, what does the future hold for cosmology? Well, it's an exciting prospect. As technology advances, so does our ability to observe and understand the universe. New telescopes more powerful than anything we've seen before are being built. They will allow us to peer deeper into the cosmos, to see things we've never seen before. Maybe, just maybe, they'll provide a glimpse into the era before the Big Bang. Perhaps they'll shed light on the physics that governed that time, the conditions that existed. They may even help us answer the ultimate question: what was before the Big Bang? It's a thrilling journey, one that we're all a part of. Each new discovery, each new piece of the puzzle brings us closer to understanding our universe and our place in it. It's a journey that's far from over. The future of cosmology is bright, filled with potential and brimming with unanswered questions. While the question remains unanswered, the journey to discovery is just as thrilling. So, we've journeyed through theories and concepts that challenge our understanding of the universe. We've pondered the Big Bang theory, grappled with the elusive concept of before, and dipped our toes into the quantum gravity era. We've even navigated the mind-bending multiverse theory, and in the end, we've stood on the precipice of the unknown, gazing into the future of cosmology. While we may not have a definitive answer to what was before the Big Bang, it is the exploration of these possibilities that propels science forward. It's the relentless pursuit of knowledge, the insatiable curiosity, that fuels our progress. We've unraveled mysteries and posed new questions, pushing the boundaries of what we know, and what we have yet to discover. If you enjoyed this journey through time and space, please subscribe to our channel and hit the like button. Your support helps us bring more such intriguing content to you. Until next time, keep wondering, keep exploring.